कौन भाई कैसे हो? How are you doing? I hope you are doing good. So we should proceed with the next unit. And in the last lecture, we were talking about the enzymatic antioxidants. We discussed about the free radicals, then oxidative stress, and then how that oxidative stress can be reduced, diminished. That is with the help of antioxidants. And in antioxidants, we talked about the enzymatic oxidants. We talked about three important enzymes: superoxide dismutase, glutathione peroxidase, glutathione reductase. We talked about catalase, also glucose 6-phosphate dehydrogenases. Okay, the cell is equipped with these enzymatic antioxidants. So, what is the need of non-enzymatic antioxidants? The need is there because these enzymatic antioxidants cannot deal with hydroxyl radical. They cannot deal with peroxy radicals. They can deal with superoxide anion, they can deal with hydrogen peroxide, but what will happen to that very dangerous and very reactive radical, that is hydroxyl radical, OH radical? What will happen to lipid peroxy radicals? So to deal with them, nature has given the cell, the organism, some non-enzymatic antioxidants. Non-enzymatic antioxidants we consume through diet also. Non-enzymatic antioxidants go to the cell only through diet, only through our food. There is no way out that they can enter into the cell. They can go to the cell through our food. People classify them into water soluble non-enzymatic antioxidants. They classify next that these are the lipid soluble antioxidants, and there is a third category also which we do not find mainly in books, that deals with some other antioxidants like metallothionein, some elements which work as an antioxidative mechanism, some hormones that also work as an antioxidants. So we shall be discussing them one by one. Let us first start with the lipid soluble antioxidants. And when we talk of lipid soluble antioxidants, the first antioxidant that comes to our mind is vitamin E. Technically, it is called as alpha tocopherol. Alpha tocopherol is present at the membranous level also, because it is there at the membrane, and it is lipid soluble, so it is very easy for alpha tocopherol to capture the radicals formed there, and it captures them and then it changes them into alpha tocopheroxyl radical. Alpha tocopheroxyl radical, that is the very important thing about vitamin E. You see, vitamin E is present in green vegetables. We take green vegetables, we take vitamin E. Vitamin E is available in commercial, in the form of tablets or capsule also. Avion, that is green in color. Why it is green in color? Because it comes from vegetables, green vegetables. So almost all green vegetables are rich in alpha tocopherol, and the function of the alpha tocopherol is to remove the hydroxyl radicals by changing them into tocopheroxyl radicals. That is the importance of alpha tocopherol. There is another one which is very important antioxidant, lipid soluble, and lycopene. Lycopene comes from tomato. The red part of the tomato, the pulp part of the tomato, contains lycopene. Lycopene protects against free radicals. Lycopene has been found to protect the myocardial infarction, that is the heart problems. They can also be protected with the lycopene. There is another one, lutein. These are all lipid soluble antioxidants. tocopherol, lycopene, leucine, ubiquinol. Ubiquinol is present at the membrane between the outer membrane and inner membrane also. And this ubiquinol function is to even at the in the mitochondria, these free radicals at the level of the mitochondria are removed by the ubiquinol. Ubiquinol, and that there is one very important issue that the alpha tocopherol and ascorbic acid they work together. Ascorbic acid water soluble, tocopherol is lipid soluble. But sometimes it happens that ascorbic acid changes these these free radicals into ascorbates. And that ascorbate, the relationship between the tocopherol and ascorbic acid is that tocopherol changes into tocopheroxyl radical, and the remaining, if it is not consumed, it interacts with ascorbic acid and changes into ascorbate, and that ascorbate is again used by the cell. So the one is water soluble, another one is lipid soluble, but they are both coordinated with each other. In many toxicology books, you find that their interaction is described at the molecular level or the membrane level. In addition to these, beta carotene. Beta carotene is a very important antioxidant. Beta carotene is present in papaya. Beta carotene is present in carrot, the yellow part of the carrot. Beta carotene is present in mango. So we take these antioxidants through diet, and beta carotene helps in removing the hydroxyl radicals at the cellular and the molecular level. Then there is another one which is very important, that is the lutein, and there is another one. This is ubiquinol we have talked about. Lutein also helps in removing the hydroxyl radicals. As far as the water soluble antioxidants are concerned, the non-enzymatic antioxidants we are talking about, next to ascorbic acid is very important. Ascorbic acid is vitamin C. Ascorbic acid, you see, is suggested even against coronavirus, because it increases the immunity, because it helps in removing, if you talk at the molecular level, it helps in removing the OH radicals and the LOO radicals, LOOH radicals, and peroxynitriles, peroxynitrous acids, even the radicals which are formed after exposure to pollutants like nitric oxide, nitrogen dioxide gas, sulfur trioxide gas, ozone. They are dealt by the antioxidants at the cellular or molecular level. In addition to ascorbic acid, we have one very important, there is a list of, you see, urate, then glutathione. Glutathione we have discussed in a separate lecture. Glutathione is inevitable. Glutathione is required. From where glutathione goes? Glutathione is synthesized by the liver. A very small amount of glutathione is there in liver. It is always available to fight against the free radicals. Glutathione is water soluble. We need not to discuss all that because we have already discussed at length about glutathione. Next is the glutathione precursors, cysteine, methionine. They are also very important. Cysteine and methionine, cysteine, methionine, they come from diet. We take them from diet, from food, and they are available for the synthesis of the glutathione in the cell. And as soon as the glutathione requires them, they are used for the synthesis. Then there is another one, bilirubin. Bilirubin is present as a component of the blood. Hemoglobin is, I tell you, is a very important antioxidant. Hemoglobin protects against or scavenges many of these radicals. The same is with bilirubin. Bilirubin and biliverdin, they just scavenge. Arsenic, when it it generates the radicals. Those radicals are eaten up or are complexed by the bilirubin, and they are then they go to the bile and they settle down there. They are no more available for circulation in the blood or in the body. So these pigments are very important. In addition to them, we have got certain antioxidant proteins, the protein thiols. Then we have got albumin, we have got transferrin, we have got ferritin, ceruloplasmin. Ceruloplasmin is copper containing protein. Then haptoglobin. Ceruloplasmin is very rich in invertebrates. Ceruloplasmin is not that much in vertebrates or in man, but ceruloplasmin plays a very important role in scavenging the radicals. They directly bind with these proteins which are present in the cell or which are present in the blood. Albumin is very important. Hemoglobin is very important. Urate is very important. They are already present there. We need not to do anything because they come through diet. In addition to that, I would like to discuss with you some wonder molecules which are playing a very important role as antioxidants. And one of those wonder molecules is metallothionein. Metallothionein was discovered by Margoshes and Wali in the kidney of horses for the first time. And metallothionein were induced by the metals, especially by cadmium in the kidney. And it was found out that these metallothioneins are the sulfur clusters. But the experiments that we performed in our laboratory, we found that these metallothioneins are highly efficient in removing the free radicals from circulation, removing free radicals from the cell, from the cytoplasm. Metallothioneins are different types. If cadmium is inducing metallothionein, it is cadmium induced metallothionein. If zinc is inducing metallothionein, it is zinc induced metallothionein. When we discuss about the toxicity of metals, we shall be talking about these metallothioneins in details. Zahir Sheikh, Professor Ulmer, Professor Wally, Professor in Switzerland, I'm forgetting his name, they have done a lot of work. Suzuki in Japan, they have done a lot of work on metallothionein. We too have found very good results on the protective effects of metallothionein against cancer-causing agents like dimethylnitrosamine. Metallothionein, we have a couple of papers on metallothionein. Its scavenging role of metallothionein has been established by different laboratories, including our own laboratory. Then metallothionein, zinc, I just talked about you, zinc. Zinc is a very important antioxidant element, I tell you. And the protection offered by zinc is only through zinc metallothionein. Recently, we published a paper on nano zinc, and we found that nano zinc is also protective against a cancer-causing agent dimethylnitrosamine by inducing the metallothionein component. So metallothionein is an established antioxidant. मेटलोथायनिन पर तो कोई शक ही नहीं है कि हाँ ये एंटीऑक्सीडेंट नहीं है. It is an established originally when we discovered it was discovered, nobody said that it may be having an antioxidative role, but slowly when people started studying the biology of this important molecule, they found that yes, it is having a very important role in the cell, and that is as an antioxidant. As far as the elements are concerned, zinc is very important. Zinc is a membrane stabilizer. Zinc is a free radical scavenger. Zinc is a very important antioxidant. We take zinc through diet. The marine food is very rich in zinc. The vegetables are not that much rich in zinc, but those people who take the seafood, especially these mollusks, the oysters, they have very high amount of zinc. Even fish contains the high amount of zinc, and that zinc is available in the cell to fight against the free radicals. The another important element is selenium. We were talking about selenium. On cysteines, we were talking about the selenium system, right? And we said that selenium is required by enzyme glutathione peroxidase. It is selenium dependent enzyme. Without selenium, glutathione peroxidase cannot work. So selenium has bound. One of my students worked, and we compared the free radical scavenging activity of selenium, vitamin E, and glutathione. And we found, when we compared the efficacy of these three antioxidants against free radicals, we found that selenium possesses a very strong antioxidative activity. So selenium comes to us through diet. The wheat flour that we consume contains selenium. Many of the other dietary components of fruits and vegetables, they contain selenium. Even milk contains selenium, milk contains zinc, milk contains calcium. So, the selenium again is a very important antioxidant. In addition to that, I would like to discuss about the hormones also. This information is about the metallothionein and selenium and nanozinc or zinc. This information is not available as an antioxidant scavengers, but I am telling you from my own experience and from the experiments that we perform, there is another one very important hormone, melatonin. Melatonin is a light synchronizer. Melatonin tells us that now it is time for you to sleep. Melatonin tells us that it is time for you to wake up. Melatonin plays a very important role in photoperiodism. Melatonin plays a very important role in circadian rhythms. So, from where melatonin comes? Melatonin comes from the pineal gland, and pineal gland is situated just near the pituitary in the brain. It's a very small gland, but it is photosensitive. The photons which are received by our eyes, that information is given to the pineal gland, and the pineal gland secretes melatonin, and melatonin comes to circulation, and it is the melatonin that advises us that now it is a time for you to sleep. So melatonin is a very important hormone. There is a journal known as Journal of Pineal Research. So that Journal of Pineal Research, a writer is the editor-in-chief, that publishes all papers dealing with the pineal gland and the melatonin hormone. And melatonin hormone has been found to be protective against many of the xenobiotics. And the theory that, or the hypothesis that we have raised, is that melatonin possesses a general antioxidative activity. It is a general antioxidant. Whether you take carbon tetrachloride, whether you take alcohol, or you take paraquat, or you take any poisonous element, arsenic, you will find that we have published good papers on. There are, if you go to the PubMed site and you find the protective effects of melatonin against benzene, there are only 4 papers, and 2 papers come from our laboratory, where we have established that melatonin is a very good, very potent, very effective antioxidant, and people are searching the effects of melatonin against carbon tetrachloride, against acetaminophen, against dimethyl nitrosamine, and so many other xenobiotics. So, in total, what do we have? That this is not the enzymatic machinery, because enzymes can deal only with superoxide anion and H2O2, but there are variety of free radicals which are formed at the cellular, at the molecular level, and to deal with them we have got proteins, we have got hormones, we have got molecules, water molecules like glutathione, we have got metallothionein, we have got even pigments like hemoglobin, ceruloplasmin. They all are helping this cell to survive against the abuses against the bad effects of the environmental pollutants, of the drugs, of other chemicals, polluting gases, blah, 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 blah. So, this all makes the enzymatic as well as the non enzymatic antioxidant system, and that works at the membrane level, that works at the mitochondrial level, that works at the cytoplasmic level, and these antioxidants are in the circulation. Whenever the cell needs them, they go scavenge the free radical, remove it or neutralizes it or changes into something which is less harmful to the body, and thus helps the cell to survive. So I think I'm clear about the non-enzymatic antioxidants. It's just a brief idea. Uh, I have much information available on these antioxidants, but that cannot be discussed at this moment. We will discuss it some another time. So thank you very much for watching. Enjoy studying.